All right. 3-1, day 2.
I got the...
Huh? Kind of big. I thought it was short, but I got a lot going on in here. 1, 2,
I got a lot going on
3,
here,
4. I got 5 pages again.
It's more like your water napkin from all the swimming.
Okay. If you flip a coin 3 times, find the following probabilities. And I've got 4 probability questions for you. What's the probability that you flip exactly 2 heads? So we'll write them all down first. What's the probability that your last 2 flips are heads? What's the probability that you get less than 2 heads? And what's the probability that you get no more than 1 head? Okay. Get all that down, then we'll discuss. Anytime you're doing probability, the first question you got to ask yourself is, how big is the sample space? How many outcomes am I looking at? So I'm flipping 3 coins. Do you know how many outcomes there are going to be? 8, because what are you comparing it to? Probably the boy-girl thing from yesterday, or it's 2 times 2 times 2. Because I'm asking some very specific questions here, do you think a tree diagram might be best so you can actually see those outcomes? Other than knowing that there's 8, I personally would. If I had this many questions and I got to know exactly 2 heads, I'd hate to miss one when it's a pretty easy problem. So we should get 8 outcomes in the end, but let's take the time to make the quick tree diagram for heads and tails. And it's a 3-part experiment. So always start your tree diagram with the dot. If you want to list them out at the end, what each branch represents, it's going to make the probability questions super easy. So, right away I know all 4 of these answers, my bottom number is 8, because there's 8 outcomes here. I want you to go ahead and fill in the top numbers on your own, see if you can read your table correctly, and then I'll ask. So go ahead and figure out how many events match what we're talking about in each of those 4 probability questions. So on your own, figure those 4 out. Sometimes it's nice not to be led to the answer every time. Then if you're thinking wrong, you can see it and fix it right off the bat. If you do get them wrong, we can go back and look and see which ones you're supposed to be counting. Okay, what's the first one? Anybody? 3 out of 8. Let me know if you disagree. The second one? 2 out of 8 reduces down to 1/4. Next? 4 out of 8 reduces down to a half. And? 3? Last two are totally different? Okay, let's check. Less than 2 heads. So that means we're looking at 1 head or no heads. So, 1, 2, 3, 4. I do agree with the 4 over 8 here. Okay? And you got a different one for here. No more than 1. So what does that mean? What does no more than 1 head mean? What are we going to count? The ones with 1 or 0. Should be the same as C. Those two questions are exactly the same. So this should be a 4.
What would it say if it was, would it say only 1?
Exactly 1, yeah, or only 1, yep.
Wait, for B, I only got 1. What did I do wrong?
Last two are head. That would be
That's that one.
this one
Oh, okay.
and this one.
Wait, for D.
D. No more than 1 means I can have 0 or 1. Okay? See how nice it is to kind of do them yourself a little bit first? Are we good? Okay. That page. Okay. If we roll 2 dice, so this question comes up a lot too. What's your sample space going to be for that if you're rolling 2 dice instead of just 1?
36.
36. A lot of people will say 12 there, because it's 6 outcomes times the 2 dice. But we're going to start the tree, we're not going to do the whole thing. So we're going to roll 2 dice, and there should be 36 outcomes in the sample space. But let's see where that comes from, because I don't think everybody would have had that right off the bat. Because it would be an obnoxious tree to make completely. So when you roll the first die, you've got your 6 outcomes. You can roll a 1, a 2, a 3, a 4, a 5, and a 6. But then off of each one of those, when you roll the second die, you've got 6 outcomes. So every one of these branches has 6 coming off of it. So that's 6 sets of 6. So it's 1, 2, 3. So you've got 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. And then see 2, 1, 2, 2, 2, 3, 2, 4, 2, 5. You know, just see those all in your head. I don't want to take the time to write all of them in. But you get the idea, correct? 1, 1, 1, 3, all the way down. Okay, so have a vision for that. There's 36 outcomes. So now, my probability question. What's the probability that you roll a set of dice and you get a sum of 7? So your best bet on this is to go down each branch and write down the outcomes that would mean a sum of 7. So if we start on this first branch, are there any pairs of numbers that add up to 7? I've got a 1 first. I have to have on this branch, if I'm counting, it's 1 and 6. I'm just going to go right down.
Oh.
Okay, now I'm on the second branch with a 2 first. Is there anything that makes 7? 2 and 5. Next. 3 and 4. The next branch. 4 and 3. The next branch. And then so there was 1 on each branch. So that means there are 6 outcomes in that sample space of 36. Which gives us 1, 6. You do the next one. It's the probability that you roll a pair. See the tree? Is it the same? Yep, there's 1 on each branch. 1, 1, 2, 2, 3, so it's 6 out of 36. And then the last one, what's the probability that your sum is less than 4? Go ahead. Is it 4? Did you list them out? 3. What did you pick out? 1 and 1. 1 and 2. And 2 and 1. Best to list them out, and it is 3 out of 36, or a 112. Okay. In the gambling world, if you ever buy lottery tickets, or you go to the casino, they use something similar to probability, but not quite. You know what they use to give the chance of winning something? They don't use probability. You must have seen it. They use odds. The odds of winning. Horse racing, the odds on this horse. It's all odds. And we're going to look at how odds compares to probability. I like those odds. Okay, so odds. And you're going to say, we're going to see why they use odds and not probability, even though the number's representing the exact same thing. But they're going to look way different. So the odds are another way to indicate the chance of an event happening. And usually it's the odds of winning. So it's the probability of you winning. Okay? And it's the gambling world that uses this. Anytime McDonald's has those little games and they give the odds of winning, all that stuff, when they have their Monopoly game and everything else, you'll see the odds that you win something. Okay, what odds does is it breaks up the sample space. With probability, we always compare to the total sample space. Odds breaks that sample space apart. So it breaks the sample space apart into the number of successful outcomes, winning outcomes, successful outcomes, and it's usually written as a ratio, compared to the number of unsuccessful outcomes. So when you add these two numbers together, that's going to give you what was your sample space. So these two added together we're going to start with something real simple, and you're going to see why odds are used over probabilities in gambling. They think they're fooling you. And they do fool most people. Ready? Yeah, sounds better. Okay, so let's say your game, got a little carnival game, over at Cameron there, you're in charge of the game, and your game is to have the little kids roll one die. And they win your game if they roll a 5 or 6. You're a winner and give them a little prize. So my question is, what's the probability that a kid wins? Two out of six. So our sample space is 6 because we've only got the one die. They win on 2 different numbers. So it's a 2 out of 6. So 1/3. What that means is 1/3 of the time you expect a kid to win. So 1 out of every 3 kids should win your game. If it's played long enough, that's what that winning ratio is going to be. That's what a probability is telling us. Now let's do the odds of winning this game. Odds of winning. So we write it as a ratio of 2 numbers. How many successful outcomes are there on the die? 2. How many unsuccessful outcomes are there on the die? 4. See how these 2 numbers add up to the sample space? What's a 2 to 4 ratio reduced down to? 1/2. So if most people saw that, what would you think?
50%.
You have a 50% chance of winning the game. You got a 1/2 chance of winning the game. Is that true? No. You're only going to win 1 out of every 3 tries. Odds look a lot better. That's why they do it. So don't be fooled by the odds. Figure out the probability. All right. So what's the probability that you lose the game? So, how many losing numbers are on the die out of the total sample space, because we're doing probability? Four out of 6, so 2/3 probability of losing. Lose 2 for every 3 times you play. The odds of losing? So I'm looking at losing, so that's my successful outcome is losing, so you guys think how many numbers are losing? 4 to 2, or a 2 to 1. Lose 2, win 1. Okay, let's see how good you truly understand odds here. So we got a new game. And the probability of winning this game is set at 3/7. I'm only going to ask what are the odds of winning this game. How do you turn that probability into odds? What is my sample space? 7 is my sample space. That's perfect. There's your sample space. Now you got to break it apart. So your 2 numbers should add up to 7. So how many successful outcomes are there? 3. So how many unsuccessful outcomes are there? 4. 3 to 4. Looks good. Win 3/4 of the time you play? No. Means you win 3 times and you lose the next 4. No, unless you do it 1,000 times, then it does. It's called the law of large numbers. The more you repeat an experiment...
That's actually what it's called.
Yep, law of large numbers. Okay, let's play some craps here. And then we'll be done.
What?
Craps? Craps tables?
Never edge.
You see it on TV shows. People standing on the table, they roll the die, and everybody's cheering.
Let's
I have no clue how they play it.
I got a little bit of it. I've never played it, but I know there's all kinds of different betting and stuff. So I've got a little bit on craps.
Why do you want to watch other people win on TV? Yeah.
It's fun. Maybe they'll throw a chip your way because they're so excited they're winning tons of money.
I tried to suck up.
Okay, in craps,
Yeah.
You know you love it on the inside. You love it on the inside.
Is this going to be more than 5 lines?
yes.
Like it. I'm not glad it's probably.
I have 2 keys if you want to flip a coin.
Okay, in craps you roll 2 dice. And then there's situations. On your first roll, you win If you roll a 7 or 11, you lose if you roll a 2, a 3, or a 12. You get to roll again if you roll a 4, 5, 6, 8, 9, or 10. This is called your box point. Your second roll, so if you get a roll again, you win if you roll your box point, whatever you get here, before you roll a 7. So it could be second, third, fourth. So you would repeat until you either win or lose.
It's so complicated.
A little bit. Okay, so because we're rolling 2 dice, what's our sample space consist of? 36 outcomes in the sample space. You always want to keep track of that sample space. All right, first question. What are the odds that you win on the first roll? So we only win when we roll the 7 or the 11. So it would be nice to know how many ways there are to roll a 7 and how many ways there are to roll an. So go through that tree diagram, starting with the 1. We did 7. What was it? How many were there? Oh, there was 1 in each one. So there's 6 ways here. Okay. How about 11? Where are they?
5 and 6, 6 and 5.
5 and 6, 6 and 5. Are we in agreement with Danny? Everybody see it? So there's 8 ways to win. So 8 successful outcomes. How many unsuccessful outcomes? 36 minus 8 is 28. Which reduces down to 2 to 7. What are the odds of losing on the first roll? And they take your money.
Higher than they'll tell you.
So the odds of losing. So I lose when I roll the 2, a 3, or a 12. So how many ways can you get a 2?
1.
Just 1. The 1, 1. A 3 is what? 1, 2, and 2, 1. So the 2 first branches. A 12. There's only 1 on there, the 6, 6 at the bottom, very last outcome. So that makes 1, 2, 4 ways to lose. And if sample space is 36, 32, that reduces down to 1, 8. Oh, I don't think I'm gonna do that last one. I did the odds of winning on the second roll, but it's a different odd depending on what your box point was. So we don't need to do that, I don't think.
Okay.
I think you'll be fine.
Yeah.
That's it.
Sweet.
Page 111. We're gonna pick up
133.
11, 12, 13 to 25 odd. You can skip 15 because you did it yesterday. And then 29 to 34 are your odds. There you go. That shouldn't take too long. Then you got lots of time.
So we can skip 15 now.
Yep. Unless you want to do it again because you missed it yesterday.
29 to 34.
That's all.
Oh.